Hi there, this is Pablo Gomez, and today we are going to present our work Wodel-Edu, a tool for the generation and evaluation of diagram-based exercises. This work has been done along with Esther Guerra and Juan de Lara. Well, to start with this presentation, we are going to describe the motivation behind this work. So there is a lack of frameworks to generate domain-independent exercises, and there is a need to generate a high number of them. So an assistance tool of this kind would alleviate much of the professor's work. So we proposed an extension of the Wodel tool for model mutation to generate and evaluate diagram-based exercises for any domain. And as a result of this proposal, we have created the Wodel-Edu tool that we are going to present today. So the overview of the Wodel-Edu tool is that we create a meta model. We define the concrete syntax by means of the model draw DSL, then we define the mutation operators by means of the Wodel DSL, and then we define the textual representation of the elements by means of the model text and mutatext DSLs. After that, the professor generates the seed models or inputs them by hand. He defines how the exercises are going to be generated and generates them. There are currently 7 kinds of exercises, and after that the exercises can be solved and graded for the students. So these are the 8 steps in which we have divided this tool demo. First we create the meta model, then we define the concrete syntax, we define the mutation operators, the textual representation of the elements, the exercises description, the automatic generation of the exercises, and the exercise solving and automatic grading for the students, as we have said in the previous slide. So first we create the domain meta model. Is going to be seen in the next. We load or create the domain meta model. This is the first step. We create the Wodel-Edu project. We input the project name and the main Wodel mutator file, and we select in the drop-down list the Wodel-Edu extension. We input the eCore meta model. In this case, corresponds to a logic circuit domain, and we generate the Wodel-Edu project with this configuration. And well, we have in the left side of the screen the generated resources for the Wodel-Edu project with the domain meta model. Well, after that we define the concrete syntax of the domain, the graphical syntax by means of the model draw DSL. So we can use this template for that, and we use the syntax completion facilities. In this case, the logic gates are going to be represented as nodes with a logic shape. We complete the rest of the representation. And after that we define the mutation operators of the desired exercises by means of the Wodel DSL. We need to specify the directive blocks for each mutation operator, and this mutation operator retypes an AND or an OR gate as a different, for example, an AND gate by an OR gate and the other as well. So we save it. We also can input the number of mutants for each mutation operator, and we complete the specification. After that, we define the textual representation of the models by the model text and mutatext DSLs. This is the model text DSL. We define here the text change an AND gate to an OR gate, for example. So we need to input here the how the gates are going to be named. So this is an AND gate. We also specify that the input gates, they are specified as inputs, and the rest of the specification. And after that, the mutatext specification, we define here this text representation of the mutation operator that we are applying. In this case, change an AND gate to an OR gate, as I was saying before. So the object retyped mutation operator changes an AND gate, for example, to an OR gate, or an OR gate to an AND gate. And also the reverse mutation operator if we need to undo the mutation operator for the text options of the exercises. Okay. After that, the professor describes how the exercises are going to be generated. He can select 7 kinds of exercises provided. For example, alternative response, multiple choice diagram, multiple choice emendation, match pairs, missing words, if we allow reattempts or not, and also using the alternative textual representation. We define here for the corresponding domain models which statement has each of the exercises. For example, does this logic circuit correspond to the below Boolean expression? In this case, the Boolean expression is automatically calculated by this alternative textual representation extension point, and we complete the specification. We save it, and after that the professor can automatically generate the exercises. He can select for the corresponding platform in the preferences page. Also, he can select this different configuration, the models validation, the model comparison, also the semantic comparison of the mutants, and in the Wodel-Edu preferences, the target platform, the model draw renderer used, in this case the circuit macros, and we are ready to generate the exercises. We just right click on the Wodel mutator file, execute mutations, and after the mutation the mutants are generated, the tool automatically generates the needed resources for the configuration included for the application of exercises. So it has generated here the Moodle question bank for this configuration, and these are the generated mutants. Then the students can solve the exercises. First, we show the generated exercises for Moodle. So we just allow time to the students enough time to solve the exercises. This is a text drag and drop kind of exercise. These exercises are of the kind missing words. As we can see, we need to complete the blanks of the statements. These are the exercises of the kind match pairs. So in the left side there is a Boolean expression, and in the right side it is the applied mutation operator in natural language. These exercises are of the multiple diagram choice, so we select one randomly, and these are of the alternative textual response. Of the alternative textual response kind. These are of the type multiple emendation choice. And this last page corresponds to exercises of the alternative response kind. So we can submit all and finish, and after that we show an example of exercises generated for the domain, for the target platform of the Android mobile OS. So this, just to mention that this code generator was done by Andrés Rico Fernández. This is the generated application for the Android system, and the mechanism to complete the exercises is the same as in the case of the Moodle platform. And this is the resulting generated exercise for the iOS operating system. This work was done by Jaime Velázquez Pazos, also a bachelor student. It meant his final bachelor thesis, and in this case we have applied the generation of exercises to the domain of deterministic finite automata. As we can see, well, these are just some examples of the generated exercises for the iOS platform. And these are the exercises generated for the web. They are also for the domain of deterministic finite automata. We select the target platform in the preferences page, and we can see in the left side that an HTML file is generated with a specification, and we load it into a web navigator. And as we can see, these are some examples also for this deterministic finite automata, also with the same kinds of exercises, but in this case the graphical representation is using GraphViz tool. And now we can show the automated grading of the exercises. These are for the Moodle platform. We can see that the ones that we completed randomly have been wrong. And the conclusions: Wodel-Edu automates the generation and evaluation of online exercises by using a model-based approach. It is domain independent and supports automated grading and enables a large-scale generation of 7 kinds of exercises. The Wodel-Edu tool automates the generation of scene models and alternative textual representations. As a future work, we plan to extend the Wodel-Edu tool to support gamification and other types of exercises, for example, supporting interactivity via direct diagram manipulation, etc. And we also plan to use Wodel-Edu in other domains, such as software design, electric circuits, and etc. So, well, the presentation has ended. Many thanks for your attention, and well, have a good day. Thanks.